Hi everyone, welcome back. Yesterday we learned about surface area. Today we're going to learn about volume. This is the last lesson for this chapter about solids, three-dimensional shapes. So after this you can look forward to a test, and this is your last unit of the class, so you can be excited. You've almost made it through geometry. Let's talk about volume. Volume is the amount of space that a solid encloses. Here are the formulas for volume. Prism and cylinder have the same formula for volume. Note that capital B stands for the area of the base, and H has to be the height of the whole prism or cylinder. Pyramid and cone also have the same formula for volume. And then sphere has this formula, where R represents the radius. Let's do a bunch of examples together. We'll start on this one. These examples tell us to find the volume of the solid shown and round to the nearest hundredth if necessary. We will start with this. I know that the formula for this prism, it's a prism, is area of base times height. First, let's pick out the base. The base are these triangles because they are parallel to one another. We've seen another problem similar to this. In the past, we may have had to find the hypotenuse, but this time we do not. So we need to figure out how to find the area of this triangle base. Remember, the formula for area of a triangle is 1/2 base times height. Now, where this lowercase b represents the base of the triangle, and h represents the height of the triangle, times the height of the prism. Now, let's go ahead and find the area of this base triangle. So we would have 1/2 times 12 times 10. Remember, the base and the height of a triangle have to be perpendicular to each other. And next, the height of the triangle goes between, of the prism goes between the two bases, and it's represented by 11. Now we can solve this. Volume is already by itself, so we can just go ahead and plug this into our calculator to get 660. And finally, you need to write your answer with units. Volume equals 660. Now for volume, we're multiplying three things together: the base and height of the base, and then times another dimension, the height. So this is three-dimensional, so we need to use centimeters cubed. Let's do another one. This is a cone, so I know the formula is 1/3 area of base times height. I'm going to substitute in the formula for the area of the base. A circle area is pi r squared. Now I can substitute in my numbers here. The radius of the base is 3.2, and the height of the cone is 5.8. I can solve it. It's already solved for volume. Volume's already by itself, the variable. So if you wanted to solve it for an exact answer, you could leave out the pi when you first calculate it. So it would be 59.392 pi over 3. If you plug that into your calculator, or if you just did this from the beginning, that's fine too. Your answer would be 62.195. So your answer with units, you could round up. 5 should round up. So we'd have 62.20, because the 9 would round up, causing it to be 20, and this would be meters cubed. Alright, let's go to C. This is a cylinder, so I know the volume is area of base times height. The cylinder, the base is the circle. I know that to find the area of a circle, I use pi r squared. Now, 9 inches, it's the pink segment going fully across the circle through the center. That means it's the diameter, giving us a radius of 4.5 inches. So I can substitute in my numbers here. Radius of the base is 4.5 inches. Square that. Now the height goes between the two circles, the two bases. It's 5 inches. Solve. Volume's already by itself. If you wanted an exact volume, you could type in just the numbers without pi to your calculator to get 101.25 pi. And An approximate answer for this problem would be 318.086. So my answer plus units volume for this cylinder is 318.09 inches cubed. Next, part D. This is an oblique prism, but it still uses the same formula for volume. It's area of base times height. This one already gave me the area of the base is 17.3 centimeters squared. And the height, remember, is the altitude of the shape. The 6.4 centimeters is the altitude of the shape, the height of the shape. I can solve this. Volume is already by itself, so I'll just go ahead and plug it into my calculator to get 110.72. So my answer plus units, volume equals 110.72 centimeters cubed. Now let's pause for a minute on these problems and think about what does this mean. Basically what this means is that you could take 110 plus a little bit more of 1 centimeter by 1 centimeter cubes and fit them inside of this prism. So a little more than 110 of these cubes that measure 1 centimeter by 1 centimeter by 1 centimeter can fit inside here. Alright, let's keep going. Part E. This one's a little challenging because we are not given the radius and we need to find it. And we have this angle 58 degrees. Let's go ahead and start by labeling. It's not a special triangle and we don't have two sides. If we had two sides, we could use Pythagorean theorem. If it was a special triangle, we could use either our 30, 60, 90 or our 45, 45, 90. Our last resort, though, is to use SOHCAHTOA. Let's start by labeling the sides. So opposite of 58 degrees is 11. Adjacent to 58 degrees is the radius. Which trig function uses opposite adjacent? Hopefully you answered tangent. So we'll write tangent of 58 degrees equals 11 over r, opposite over adjacent. Now we've done this many times, but just as a quick refresher, we could multiply by r on both sides. Remember, it does not multiply by the angle. And then to get r by itself, we need to divide by tangent of 58 degrees on both sides. Now you have to make sure your calculator's in degree mode to be able to solve this correctly. Now that we have the radius, let's go ahead and use our formula. Substitute in the formula for area of the base. The area of the base is pi r squared because it's a circle. So let's substitute in our numbers. The radius of the circle we just found is 11 over tangent 58 degrees. We have to square that and then multiply by the height of the cone, which is 11. Now to solve, volume is already alone, so we can just go ahead and plug this into our calculator. When we plug it in, we get 544.23 inches cubed. So our answer with our units, I already kind of did that there. 544.23 inches cubed. Alright, let's go to F. This is a sphere. The formula for volume of a sphere is 4/3 pi r cubed. This one's pretty straightforward. We can go ahead and substitute in the radius. It's given to us 6 centimeters. Solve it for volume. We have 4/3 pi times 6 cubed, which gives us 288 pi. Now, if we wanted to get an approximate answer, we could multiply this out on our calculator, and that gives us 716.283. So for our answer with units, volume of the sphere is about 716.28 centimeters cubed. Okay, let's continue to this last problem. We have a pyramid. This is a rectangular pyramid because I can tell that these two sides are not congruent. Therefore, it's not a square pyramid. It's a rectangular pyramid. I know in order to find the area of this base, I'll have to take the length times the width. So I can substitute in my numbers. Length times width, I have 9.5 times 8. The height of this pyramid is 9 centimeters. Solve it. Volume is already by itself, so you can go ahead and plug this in. That gives me 228 exactly. So my answer should be the volume of this pyramid is 228 centimeters cubed. On the next page, I have a lot of problems for you to practice. You can go ahead and pause the video and try those now. I will show you the answers when you get back. Alright, here's the answer for A. Hopefully you remember that to find the area of a regular polygon, you take 1/2 the perimeter times the length of the apothem. Remember, the apothem goes perpendicular to the side from the center. It's that segment there. And I knew this was regular because it has all the sides marked congruent. So that's how I knew I could use this formula to find the area of the base. Here's part B. This is a cone. Part C, we actually did have to find our missing side here to be able to find the area of the triangle. That's the base. Here's part D, another cone. Part E is another cone. This time we had to use a 30, 60, 90 triangle in order to find the radius of the base. And finally, part F, we have the base of the area of the base is given to us and the height is given. You can find the volume. Whoops, sorry, one more. This sphere on the next page, the diameter is given, so we can find the radius, plug it in to find the volume. Alright, challenge problem. The containers shown below are filled with popcorn. About how many times as much popcorn does a larger container hold? You can try that problem and see what you think. And finally, reflect on this question. A standard juice box holds 8 fluid ounces. Sketch designs for 3 different juice containers that will each hold 8 fluid ounces. Label your dimensions in centimeters. That's all I have for you. That is the end of the unit. That is the end of geometry. You can do a little happy dance celebration. You've made it through. Congratulations. Great job, guys. See you in class tomorrow. Bye.